The morning of September 19th, 1943, Kapitän Lieutenant Werner Henke stood in the conning tower of U-515, watching through his periscope as another convoy appeared on the horizon. 43 merchant vessels arranged in neat columns, their hulls riding low in the water with cargo bound for Britain. He'd been hunting convoys like this for 3 years now, and he'd sunk his share. 17 Allied ships sent to the bottom. But something had changed in the last 18 months. Something that gnawed at him every time he raised his periscope. No matter how many ships he sank, no matter how successful the patrol, there were always more. Always. The convoys kept getting larger, the ships more numerous, the intervals between them shorter. It made no sense. The Kriegsmarine's intelligence had been clear. America's shipbuilding capacity was limited. Their industrial base stretched thin by a two-ocean war. Sink enough ships, and eventually the pipeline would run dry. Britain would starve. The war would be won. Henke lowered the periscope and turned to his first officer. They both knew what the other was thinking, though neither would say it aloud. Something was wrong with the intelligence, something fundamental, because the ships just kept coming. What Henke couldn't see from his cramped pressure hull in the North Atlantic was the answer to his unspoken question, an answer that was, at that very moment, taking shape every 10 hours and 30 minutes in 18 shipyards across the United States. An answer so audacious, so seemingly impossible by every standard of naval architecture and industrial practice, that German planners had dismissed it as Allied propaganda. They called it unmöglich, impossible. 8,000 merchant ships, built in 4 years, with America's limited experience in mass maritime construction? Unmöglich. But Henry Kaiser and the workers of America's emergency shipbuilding program didn't care what the Germans thought was possible. They were too busy making it real. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This is the story of how America built the impossible, a fleet so vast, constructed so quickly, that it fundamentally broke the mathematics of Germany's Atlantic strategy. And it's the story of the German submariners, intelligence officers, and naval planners who watched their carefully calculated war of tonnage collapse under the weight of an industrial miracle they never saw coming. To understand what made the Liberty ship program so incomprehensible to German strategic thinking, you have to understand what maritime construction looked like before 1941. Building a cargo ship was a craft. Naval architects spent months designing each vessel. Riveters worked for a year or more assembling the hull plate by plate. Each ship was a custom creation, built in Shipbuilding, specialized facilities by workers who'd spent decades mastering their trade. A good shipyard might launch 6 or 8 vessels in a year. An excellent one might manage 12. The Germans understood this. Their own shipbuilding industry operated on these principles. When Kriegsmarine planners calculated tonnage requirements for the Battle of the Atlantic, they used established industrial models. Britain had approximately 3,000 merchant ships at the start of the war. America had roughly 1,000 suitable for Atlantic service. If U-boats could sink merchant vessels faster than the Allies could replace them, a target of roughly 700,000 tons per month, the mathematics were simple. Britain's supply lines would strangle. The island nation would be forced to negotiate. And for the first 2 years of America's involvement in the war, the mathematics worked. In 1942, U-boats sank over 8 million tons of Allied shipping. The graveyards of the Atlantic filled with the wreckage of tankers, freighters, and cargo vessels. Survivors spoke of burning oil slicks, torpedoed ships breaking in half, men drowning in freezing water, while rescue ships dared not stop for fear of becoming targets themselves. By the middle of 1942, ships were being sunk faster than Britain and America combined could replace them. The German naval staff calculated that at current rates the Allies would run out of merchant hulls by mid-1943. The war of tonnage was being won. What they didn't account for was a 70-year-old industrialist from California who'd made his fortune building roads and dams, a man who'd never built a ship in his life but who understood something the Kriegsmarine's planners didn't, the difference between craftsmanship and mass production. Henry Kaiser looked at shipbuilding the way he'd looked at constructing the Hoover Dam, as an assembly problem, not an art form. In late 1940, when the British Purchasing Commission came to American shipbuilders asking for emergency cargo vessels, most yards quoted 18 to 24-month construction times. Kaiser quoted 6 months. The established shipbuilders laughed. 6 months to build a 10,000-ton ocean-going cargo ship? From a man who'd never constructed anything that floated? Impossible. Kaiser had something the traditional shipbuilders didn't. He'd studied Henry Ford's assembly line methods. He'd watched how Ford transformed automobile manufacturing by breaking complex construction into simple, repeatable tasks. He'd seen how prefabrication could slash production time, and he believed the same principles could be applied to ships. The British were desperate enough to give him a chance. In January 1941, Kaiser's newly formed shipyards in Richmond, California, began construction on the first vessels of what would become the Liberty Ship program. The design they used wasn't even American. It was based on a British tramp steamer, the Dorrington Court, chosen specifically because it was simple, proven, and old-fashioned enough that it could be built quickly with available materials. The ships would be 441 feet long, 57 feet wide, capable of carrying 10,000 tons of cargo or 300 troops. They would be powered by outdated but reliable triple-expansion steam engines, the kind of technology most modern shipyards had abandoned in favor of more efficient turbines. They would be ugly, utilitarian, and slow, with a top speed of 11 knots. Sailors would call them ugly ducklings and worse. Naval architects would criticize their welded hulls as structurally questionable, but they could be built fast. That was all that mattered. The first Liberty ship, the SS Patrick Henry, was launched on September 27, 1941, 14 months after Kaiser started building his shipyards. President Roosevelt attended the ceremony. In his speech, he invoked the words of Patrick Henry, "Give me liberty or give me death." The name stuck. These would be Liberty ships, vessels of freedom, carriers of democracy's industrial might. The Patrick Henry took 244 days to build. By the standards of traditional shipbuilding, that was already remarkably fast. By the standards of what was coming, it was glacial, because Kaiser wasn't done innovating. By mid-1943, Liberty ships were being launched at a rate that defied every assumption about industrial capacity. The 18 shipyards of the emergency shipbuilding program were producing vessels on a schedule that would have been impressive for a single ship. Richmond Yard No. 1 was launching a ship every 10 days. The Bethlehem Fairfield Yard in Baltimore was matching that pace. The Oregon Shipbuilding Corporation in Portland was churning out hulls even faster. And they weren't slowing down. They were accelerating. The yards operated 24 hours a day in 3 shifts. Workers who'd never seen a ship before, housewives, farmers, teenagers, elderly men beyond draft age, learned to weld, to rivet, to install pipe systems. Kaiser's yards hired women in unprecedented numbers. By 1943, women made up significant portions of the workforce, performing every job from welding to crane operation. Rosie the Riveter became an icon, but the reality was more impressive than the propaganda. These workers weren't just filling in for men at war, they were becoming skilled craftspeople in their own right, mastering complex industrial tasks in weeks that had traditionally taken years to learn. The training programs were ruthlessly efficient. New workers spent a week learning their specific task, not shipbuilding as a whole, just their particular piece of the prefabrication puzzle. You didn't need to understand how an entire ship went together to weld a perfect seam on a deck plate section. You needed to know how to strike an arc, maintain a consistent bead, and check your work for flaws. Kaiser's foreman discovered that workers who focused on a single task became extraordinarily proficient. A woman who welded the same type of joint 8 hours a day, 5 days a week, could match or exceed the quality of a traditional shipbuilder who performed dozens of different tasks. The German intelligence analysts, reading reports of housewives building cargo ships, assumed the vessels must be shoddily constructed, barely seaworthy death traps that would break apart in Atlantic storms. Some early Liberty ships did have structural problems. Several broke in half in heavy seas, victims of brittle steel and stress fractures in their welded hulls. But American naval architects investigated, identified the specific failure points, and implemented fixes. Crack arrestor plates were added at critical stress points. Steel formulations were modified to reduce brittleness in cold North Atlantic water. The ships kept improving even as production accelerated. By 1943, Liberty ships were proving themselves astonishingly durable. They survived torpedo strikes that would have sunk traditionally riveted vessels, their welded hulls maintaining watertight integrity, even with massive damage. The SS Richard Montgomery survived a U-boat attack, limped into port, with a hole in her side large enough to drive a truck through, was repaired, and returned to service. The SSS Stephen Hopkins, a Liberty ship armed with a single 4-inch gun, fought a running battle with a German surface raider and a U-boat, sinking the raider before being overwhelmed, the only American merchant ship to sink a German warship in a surface engagement. These weren't flimsy propaganda victories. They were operational realities that U-boat commanders encountered every time they put a torpedo into a Liberty ship and watched it refuse to sink quickly enough to prevent rescue. The ships were tough in ways that contradicted every assumption about rapidly constructed welded vessels, and there were so many of them. Werner Henke, hunting his convoys in the autumn of 1943, could see the mathematical problem developing. He was an ace by any measure. The Knight's Cross with oak leaves hung at his throat, earned through 25 confirmed kills. He knew how to hunt, how to kill, how to disappear before the escorts could localize him. But the calculus was shifting. In 1941, sinking a merchant ship meant one less vessel in Britain's supply chain, one more step toward strangling the island. In 1943, sinking a merchant ship meant what exactly? America would launch 2 more before the week was out. Sink 5, and 10 appeared. Sink 10, and 20 replaced them. The U-boat crews began to notice it first, trading stories in the submarine pens at Lorient and Brest. Convoys that should have been crippled by losses were arriving in Britain at full strength the next month. Ships that looked identical, because they were identical, pressed out of the same massive industrial mold, sailing under different names, but with the same silhouette, the same proportions, the same goddamned ugly functionality. The American ships were recognizable at a glance: boxy superstructure, single stack, gun positions fore and aft, cargo booms arranged in the same predictable pattern. They looked mass-produced because they were mass-produced, and there was something deeply unsettling about that to submariners who thought of ships as individual creations. Henke discussed it with other commanders when they returned to port. They all felt it, the sense that something had fundamentally changed in the equation. Gross Admiral Dönitz, commander of the U-boat fleet, still spoke of tonnage warfare, of sinking enough ships to break Britain's supply chain. But Dönitz was working from old numbers, old assumptions about replacement rates. The commanders at sea could see what headquarters couldn't. The numbers didn't work anymore. In September 1943, Werner Henke took U-515 on what would be his final successful patrol. He sank 4 ships, 3 of them Liberty ships. He returned to port, filed his report, accepted congratulations for another successful cruise, and then he requested a transfer to a shore position. The Knight's Cross winner, the ace submariner, the man who'd proven himself in combat again and again, asked to stop hunting. He never explicitly said why in his official requests, but his contemporaries understood. You could be the best hunter in the fleet, but if the prey reproduced faster than you could kill it, what was the point? The math had stopped working. The war of tonnage was being lost, and everyone at sea could see it except the staff officers in Berlin. The numbers tell the story the submariners were living. In 1942, U-boats sank over 8 million tons of Allied shipping. In that same year, American shipyards launched 4 million tons, roughly half what was being sunk. Germany was winning the tonnage war. But in 1943, American yards launched 12 million tons of merchant shipping. U-boats, despite operating at peak efficiency with more submarines at sea than ever before, sank fewer than 3 million tons that year. The math had inverted. For every ship the U-boat sank, America launched 4 more, and those were just the Liberty ships, the emergency program vessels. That tonnage total didn't include fleet oilers, troop ships, or the Victory ships that would begin launching in 1944, faster and more capable than the Liberties they replaced. The Kriegsmarine's carefully constructed strategy had encountered something it had no answer for: industrial capacity, on a scale that made tactical success strategically irrelevant. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German naval staff, reading intelligence reports through 1943, struggled to comprehend what was happening. The numbers they were seeing couldn't be reconciled with their understanding of shipbuilding. 8,000 emergency cargo vessels in 4 years? That was 1,200 ships per year. More than 3 ships launched every single day for 4 years straight. The mathematics were absurd. No industrial base could sustain that production rate while also building warships, aircraft, tanks, weapons, and ammunition. But the Allies weren't just claiming it. They were demonstrating it in the convoys arriving in Liverpool, in the invasion fleets assembling for Sicily and Normandy, in the supply chains that kept Allied armies advancing across Europe and the Pacific simultaneously. The evidence was overwhelming and impossible to dismiss. America was building the impossible fleet, and it was arriving in operational theaters faster than German intelligence could update their assessments. What the German planners failed to understand was the fundamental transformation that had occurred in American industry. This wasn't traditional manufacturing scaled up. It was a completely different paradigm. Henry Kaiser hadn't just built ships faster. He'd transformed ships into products. A Liberty ship wasn't constructed. It was manufactured, assembled from standardized components using industrial processes that could be replicated indefinitely. The hull plates were standardized. The engines came from a catalog. The deck fittings, the ventilation systems, the electrical wiring, all of it was interchangeable, mass-produced, designed for rapid assembly by semi-skilled workers. The German shipbuilding industry, still rooted in traditional craft methods, couldn't make this conceptual leap. Their yards employed master craftsmen who took pride in their individual vessels. The idea of reducing a ship to an assembly problem seemed to strip away everything that made maritime construction meaningful. It was industrially offensive, philosophically wrong, a degradation of the shipbuilder's art into mere factory work. But it was also devastatingly effective. The Liberty Ship program eventually produced 2,710 vessels before transitioning to the improved Victory ship design. 2,710 cargo ships, each capable of carrying 10,000 tons of supplies, launched between 1941 and 1945. The total tonnage produced was over 27 million tons of shipping, more than the entire pre-war American merchant fleet, built in less time than a single naval aircraft carrier took from keel laying to commissioning. And they did it while also building escort carriers, destroyer escorts, landing craft, fleet oilers, troop ships, and all the other vessels needed to fight a two-ocean war. The Liberty Ship program was just one piece of American maritime production, arguably not even the AILA's most technologically impressive piece. But it was the most visible, the most symbolic, the clearest demonstration that America had solved industrial problems the Axis powers didn't even realize could be solved. The scale of the Liberty Ship program becomes even more remarkable when you examine the infrastructure required to make it possible. Building ships was only part of the equation. Building the yards to build the ships, that was the foundation everything else rested on. When Henry Kaiser agreed to construct emergency cargo vessels, he didn't have shipyards. He had construction companies that built dams and roads. So he built the shipyards themselves, from nothing, in months. The Richmond yards went from empty ground to operational facilities capable of launching 10,000-ton vessels in less than a year. And they weren't small operations. Richmond Yard No. 1 covered over 60 acres. Richmond Yard No. 2 was even larger. Each yard required massive cranes capable of lifting prefabricated ship sections weighing hundreds of tons. They needed power plants to provide electricity for welding equipment. They needed rail connections to bring in steel plate, engine components, and all the raw materials that went into each vessel. They needed warehouses, workshops, administrative buildings, cafeterias to feed thousands of workers, medical facilities to treat industrial injuries. Kaiser built 4 major shipyards in Richmond alone. Oregon Shipbuilding built 3 yards in Portland. Similar facilities sprang up in Houston, Savannah, Brunswick, Baltimore, and along both coasts. These weren't temporary structures. They were industrial complexes designed for sustained, high-volume production. The investment required was staggering, running into hundreds of millions of dollars before a single keel was laid. The German economic planners, reviewing intelligence on this construction boom, should have recognized what it signified. Any nation that could build 18 major shipyards in less than 2 years, while simultaneously expanding aircraft production, tank manufacturing, and every other sector of war production, possessed an industrial capacity that dwarfed the Third Reich's. But the implications were too devastating to accept. If America could do this, if they really could conjure this level of production out of what had been, just years before, a depression-racked economy still recovering from the 1930s, then Germany had already lost. The war was just taking time to reach its inevitable conclusion. So the intelligence was questioned. The numbers were disputed. Alternative explanations were proposed. Perhaps the Americans were cannibalizing their domestic economy, stripping resources from civilian production to feed the war machine. Perhaps the quality was abysmal and most of these ships would prove unseaworthy. Perhaps this was a sprint that couldn't be sustained. American production would peak and then collapse under its own logistical weight. These theories made intuitive sense. They aligned with German experience, where war production meant sacrifice, rationing, the gradual degradation of civilian life as everything was subordinated to military needs. In Germany, total war meant every resource directed toward the front, every factory retooled for weapons, every available worker conscripted into essential industries. It meant cities darkening as power was diverted to war plants. It meant ration cards and ersatz coffee and clothes that couldn't be replaced. America's experience was completely different, and the Germans couldn't conceptualize it. The United States in 1943 was simultaneously fighting a two-ocean war, supplying Britain and the Soviet Union through Lend-Lease, building the largest military force in American history, and experiencing an economic boom that raised civilian living standards. Consumer goods remained available. Cars couldn't be purchased. Automobile plants had converted to tank and aircraft production. But Americans weren't starving. They weren't freezing. The electrical grid didn't brown out. Stores had goods on shelves. Restaurants served meals. The massive industrial expansion wasn't cannibalizing the civilian economy. It was running parallel to it, fed by an economic capacity so vast that it could support both guns and butter simultaneously. This was incomprehensible to German planners because it defied every model of wartime economics they understood. Total war meant total mobilization, meant total sacrifice. That was the iron law of modern conflict. Except America had found a way around it, or through it, or had simply possessed such enormous latent capacity that even total mobilization didn't require total sacrifice. The Liberty ship program exemplified this abundance. Each vessel required roughly 2,000 tons of steel plate for the hull and structure. The engines, triple expansion steam engines, old-fashioned but reliable, required steel forgings, brass fittings, copper piping. The propeller shaft, the rudder, the anchor chains, the cargo booms, all demanded metal, machining, manufacturing capacity. Multiply that by 2,710 ships, and the raw material requirements were staggering. Just the steel for Liberty ship hulls consumed over 5 million tons of steel plate. Germany, by 1943, was struggling with steel shortages. The Ruhr industrial region, though still producing, faced constant Allied bombing. Swedish iron ore shipments, critical to German steel production, were increasingly threatened by Allied naval supremacy in the Baltic. Synthetic materials were being substituted wherever possible to preserve strategic metals. The Kriegsmarine competed with the Luftwaffe and the Wehrmacht for available steel, each service arguing that their needs were most critical to Germany's survival. America was producing more steel in a single year than Germany had produced in the entire war to that point. And the Liberty ships were just one consumer of that production. Aircraft plants needed aluminum. Tank factories needed armor plate. Artillery required high-grade steel for gun barrels. The construction industry needed structural steel for new factories. Every sector was expanding, and somehow there was enough for all of them. The secret wasn't just America's pre-war industrial base, though that was substantial. It was the massive, rapid expansion of that base between 1940 and 1943. Steel production nearly doubled. Aluminum production increased sevenfold. Shipbuilding capacity went from virtually nothing. America had built fewer than a dozen major merchant ships per year in the 1930s, to over 3 million tons of shipping annually. These weren't theoretical capabilities. These were operational facilities, employing millions of workers, consuming trainloads of raw materials, producing finished goods that appeared on battlefields and in harbors around the world. And the Germans, watching their own production stagnate and then decline under Allied bombing, couldn't match it. More critically, they couldn't even approach the rate of expansion. Germany was fighting with the industrial capacity it had started the war with, minus whatever the Allies destroyed, plus whatever it could squeeze from occupied territories. America was fighting with an industrial capacity that grew larger every month, that seemed to have no upper limit, that produced more as it produced more because new factories enabled more production, which funded more factories. It was an economic positive feedback loop, and Germany was on the wrong side of it. The psychological impact of this disparity on German submariners became acute in late 1943. The U-boat service had always been an elite force, volunteers who understood the risks and accepted them in exchange for the glory of the tonnage war. But glory requires purpose, and by the end of 1943, the purpose was evaporating. U-boat losses were catastrophic. The Allies had cracked the Enigma codes, developed centimetric radar that could detect submarines on the surface at night, refined their depth charge tactics, and deployed escort carriers that provided air cover in the mid-Atlantic gap where U-boats had previously hunted with relative impunity. The survival rate for U-boat crews had plummeted. Of the roughly 40,000 men who served in the U-boat service during the war, 30,000 died, a 75% casualty rate, the highest of any military service in any nation during the war. You could accept those odds if you believed you were winning, if each patrol contributed to a strategic victory. But when convoys arrived in Britain at full strength despite your successful attacks, when every merchant ship you sank was replaced by 2 more before you returned to port, when the mathematics of tonnage warfare inverted from slow strangulation to an obvious losing battle, the psychological weight became unbearable. Oberleutnant zur See Peter Kremer, commander of U-333, described the shift in his post-war memoir. Early in the war, returning from patrol with tonnage claims was a celebration. Each merchant ship sunk represented a genuine contribution to Germany's strategic goals. By 1943, the same successful patrol felt hollow. The ships were still being sunk, but it didn't matter. The victory was tactical, not strategic, and everyone knew it. Some U-boat commanders became increasingly reckless, taking extraordinary risks to achieve kills that no longer affected the war's outcome. Others became more cautious, prioritizing survival over aggressive hunting, because why die for sinkings that change nothing? The psychological cohesion of the U-boat service, once defined by shared purpose and esprit de corps, began to fracture under the weight of strategic futility, and then the convoys for Normandy began assembling. In the spring of 1944, U-boat commanders returning from patrol brought reports that defied belief. The English Channel and the southern approaches to Britain were filling with ships. Not convoys, fleets. Hundreds of vessels, thousands of vessels, concentrating in British ports and anchorages. The scale suggested something far beyond normal supply operations. The Kriegsmarine intelligence staff concluded correctly that an invasion of France was imminent. The debate was where and when, not if. What the reports couldn't convey was the sheer magnitude of what was assembling. Operation Overlord, the Normandy invasion, would require more shipping than any military operation in human history. The initial assault on June 6th involved approximately 5,000 vessels, battleships, cruisers, destroyers, minesweepers, landing craft, and cargo ships. More than 5,000 ships in a single operation, and behind them, stretching back across the Atlantic, was the supply chain that would sustain them. Convoys carrying fuel, ammunition, food, vehicles, replacement personnel, medical supplies, engineering equipment, and everything else required to maintain armies in sustained combat. The Liberty ships were the backbone of this supply system. They carried the bulk cargo that kept the invasion supplied. Each ship could carry 10,000 tons, which translated to enough food to feed a division for weeks, or enough ammunition for a major offensive, or enough fuel to keep an armored division mobile. The 5,000 ships of the invasion fleet required continuous resupply, Ships would cross the Atlantic loaded with cargo, unload in Britain, load with invasion supplies, cross the Channel, unload on the Normandy beaches or in captured ports, return to Britain for more supplies, and repeat the cycle endlessly. This logistical roundabout consumed ships at a ferocious rate, not through sinking, but through sheer operational tempo. Ships needed maintenance. Engines broke down. Hulls developed stress fractures from rough seas. Collisions in crowded harbors damaged bows and sterns. Under normal circumstances, each ship in this cycle would need periodic dry docking, repairs, refitting. The operational tempo of Normandy and the subsequent advance across France should have exhausted the available shipping within months. But there were always more ships. The pipeline never ran dry. When a Liberty ship limped into port with mechanical failure, another took its place the next day. When U-boats managed to penetrate the anti-submarine screens and sink a cargo vessel, replacements arrived before the loss could be felt. The logistics of Overlord shouldn't have been sustainable at the pace the Allies maintained it, except America kept launching ships faster than operations could consume them. German commanders in France, watching the Allied buildup continue week after week after week, recognized what it meant. You could destroy an Allied tank company, kill 100 enemy soldiers, knock out artillery batteries, and the Allies would replace everything within days. The supply chain was effectively infinite from the perspective of tactical commanders. You couldn't disrupt it, couldn't attrite it, couldn't strangle it. Every tactical victory was operationally meaningless because the Americans had more of everything and could deliver it faster than you could destroy it. General Feldmarschall Erwin Rommel, inspecting the Atlantic Wall defenses before the invasion, understood the implications better than most. He'd fought the British and Americans in North Africa, where he'd seen firsthand how Allied material superiority overwhelmed tactical skill. He'd watched competent German forces ground down by an enemy that could afford to lose battles and keep advancing because they never ran out of tanks, fuel, or ammunition. He knew the invasion couldn't be stopped on the beaches because even if the Germans destroyed 50% of the landing force, the other 50% would get ashore, and then the supply ships would arrive, and then more troops would land, and then the arithmetic would take over, and Germany would lose. The only hope was to destroy the invasion at the waterline in the first 24 hours before the Allies could establish their supply system. The Atlantic Wall didn't stop them. The supply system established itself, and the Liberty ships kept coming. By the summer of 1944, German naval strategy had collapsed into a simple, desperate goal: survival. The U-boats still went to sea because the crews still volunteered and the high command still issued orders, but the pretense of winning the tonnage war had evaporated. Dönitz ordered development of the Type 21 U-boat, a revolutionary design with underwater speeds that could outrun escorts and battery capacity for extended submerged operations. If it had been deployed in 1943, it might have changed the equation. But by the time it was ready for service in late 1944, it didn't matter. The Type 21 could sink ships faster than any previous U-boat design, but America was launching ships faster than any conceivable submarine campaign could sink them. The mathematics were brutal and final. At peak production in 1943, America launched more than 3 ships per day. The entire U-boat fleet, at maximum operational tempo with every submarine at sea simultaneously, couldn't sink 3 ships per day sustainably. The best month of the entire U-boat campaign was November 1942, when U-boats sank 117 ships, an average of less than 4 per day, achieved during the second happy time when U-boats operated with near impunity off the American coast, and that rate couldn't be sustained even for a full month. By mid-1943, U-boats were sinking fewer than 10 ships per month total, while American yards were launching 90. The war of tonnage was over. Germany had lost it not through tactical failure, but through strategic impossibility. You cannot sink an infinite fleet. You cannot strangle a supply line that grows faster than you can cut it. You cannot win a war of production against an enemy whose industrial capacity exceeds your own by an order of magnitude. German planners had calculated that America's industrial base, while substantial, was fundamentally limited by the same constraints that limited Germany's production: available steel, available shipyard capacity, available skilled labor. These were the fixed points in the equation. You couldn't simply conjure up shipyards or steel mills or trained shipbuilders. Industrial capacity was finite, and warfare was ultimately a competition over finite resources. But America had changed the equation by refusing to accept those limitations as fixed. Not enough shipyards? Build more. Not enough steel? Build more mills. Not enough skilled workers? Train new ones and redesign the manufacturing process so it doesn't require traditional skills. Every constraint the Germans viewed as immutable, the Americans treated as a temporary obstacle to be overcome through engineering and investment. This wasn't a cultural difference or a matter of national character. It was a difference in economic systems and strategic thinking. Germany's war economy was subordinated to political control, with decisions made by party officials who prioritized ideological goals over industrial efficiency. Resources were allocated based on political considerations as much as strategic ones. The SS competed with the Wehrmacht for supplies. Synthetic fuel plants, critical to Germany's ability to continue fighting, received lower priority than prestige projects. The V-weapons program consumed resources that might have been better spent on defensive fighters or U-boats. America's war economy operated differently. Roosevelt created administrative structures that gave industrialists substantial autonomy to achieve production goals using whatever methods worked. Henry Kaiser didn't have to justify his shipbuilding methods to political commissars. He had to deliver ships. If his approach worked, he got more contracts and more resources. If it didn't, he'd be replaced by someone whose methods succeeded. This created an environment where innovation was rewarded, where solving production problems mattered more than following established procedures, where the goal was victory rather than ideological purity. The Liberty Ship program succeeded because Kaiser and his counterparts in other yards were free to experiment, to fail, to iterate, to find solutions that worked even if those solutions violated traditional shipbuilding practice. The emergency shipbuilding program was explicitly designed to prioritize speed over elegance, quantity over quality, delivery over perfection. Build a ship that works, get it into service, fix problems in later production runs. This was anathema to traditional naval architecture, but it was devastatingly effective at producing operational vessels. Werner Henke, who'd requested transfer from combat duty in late 1943, was reassigned to U-boat training command. He spent the last year of his service teaching new crews the tactics that had once worked, knowing they no longer worked, unable to tell his students that their training was preparing them for a war that was already lost. In April 1945, as Germany collapsed, Henke was captured by American forces. During his interrogation at Fort Hunt, he attempted to escape and was shot and killed. The official records are ambiguous about whether he was shot while fleeing or executed. The circumstances remain disputed, but his death, like his combat service, had become strategically meaningless. The war was over. The tonnage battle had been lost years earlier. Individual courage or sacrifice couldn't change the mathematics. The final accounting of the Liberty Ship program reads like a monument to industrial capacity. 2,710 ships launched, 18 shipyards built specifically for the program, over 240 million man-hours of labor invested. An average construction time across the entire program of 42 days from keel laying to launch. The fastest ship, the Robert E. Peary, completed in 4 days, 15 hours. The longest-serving Liberty ship, the SS Arthur M. Huddle, remained in service until 1948, making over 70 Atlantic crossings. 27 Liberty ships survived the war and remained in commercial service into the 1960s. 200 Liberty ships were sunk during the war, torpedoed, bombed, mined, or lost to storms. 200 ships out of 2,710, a loss rate of roughly 7%, and every single loss was replaced before it could impact operations. The Germans sank a Liberty ship and 2 more, launched that week. They sank 10, and 20 appeared. The production pipeline was genuinely inexhaustible from the perspective of anyone trying to disrupt it. This was the nightmare scenario German planners had dismissed as impossible. 8,000 ships? Unmöglich. They'd calculated it couldn't be done, created careful analyses proving it exceeded industrial capacity, written reports explaining why American claims were propaganda. And they'd been wrong about every single assumption. The ships were real, the production was real, the industrial capacity was real, and it had been real all along. Germany had simply refused to believe an economy could function that way, that production could scale that rapidly, that the constraints they viewed as absolute were actually negotiable. In the years after the war, as historians and analysts examined the conflict's industrial dimensions, the Liberty ship program became a case study in American production methods. The efficiency gains, the prefabrication techniques, the workforce training programs, all of it was studied and dissected. But the broader lesson, the one that terrified strategic planners during the Cold War, was simpler. America possessed industrial capacity on a scale that made conventional military planning obsolete. You couldn't win a war of attrition against an enemy who could replace losses faster than you could inflict them. You couldn't achieve strategic victory through tactical success if your opponent had infinite tactical resources. The Soviet Union, studying the same history, reached the same conclusion. Any conventional conflict with the United States would eventually become a war of production, and America had demonstrated definitively that it would win that war. This understanding shaped Cold War strategy fundamentally. The nuclear standoff existed partly because both sides recognized that conventional warfare between superpowers would inevitably become an industrial competition, and America had already proven how that competition ended. The Liberty ships themselves mostly disappeared after the war. Some went into commercial service. Many were sold for scrap, their steel recycled into peacetime products. A handful were preserved as museum ships or memorials. The SS Jeremiah O'Brien, docked in San Francisco, remains operational, one of 2 surviving Liberty ships still capable of getting underway. You can tour her today, walk her decks, see the cramped crew quarters, the cargo holds, the triple expansion steam engine that powered her across the Atlantic. She looks exactly like what she is, a utilitarian cargo vessel, built for function rather than beauty, designed to carry supplies and nothing more. But she represents something more than efficient naval architecture. She represents the moment when industrial warfare reached its logical conclusion, when production capacity became more decisive than tactical skill, when quantity became its own form of quality. The Liberty. Ships broke the mathematics of Germany's Atlantic strategy not through superior design or better crews or brilliant tactics, but through sheer overwhelming numbers. They were the physical manifestation of American industrial power, arriving in European ports by the hundreds, carrying the supplies that kept Allied armies advancing, demonstrating every day that Germany had lost a war of production it never realized it was fighting. The Germans called it impossible. 8,000 ships in 4 years, unmöglich. They'd calculated it, analyzed it, proven it couldn't be done, but America built them anyway, and kept building them, and the ships kept coming until the war was over and the factories could stop. 2,710 Liberty ships, the impossible fleet, the ships that broke the Atlantic, and the clearest possible demonstration that in industrial warfare, math beats courage, production beats tactics, and infinite resources make tactical genius strategically irrelevant. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.